So a very good evening to everyone. I am Sahil Gaurav, PMRF TA for this NPTEL course, Operation and Planning of Power Distribution Systems. I welcome you all in this live tutorial session, that is session number 2. Sorry for mistake. So in today's session, we are going to see problem mainly based on the demand side management about various switches we use for distribution system like sectionalizing switches and tie line switches. And we will also see problems based on the different tariff structures and on different types of busbar arrangements. So this tutorial session will help you in solving the assignment number 3, that is ongoing assignment. So before I begin this session, I just want to hear from you to, if you have any doubt and concerns about previous session, and if you have any other concern also, you can ask me. If you have anything to discuss with me or any doubts or any concern that you face difficulties in this course. Are you able to access the recordings of this video through YouTube or anyone can reply? Okay, good. Srinath, yes. Yeah, they have provided link separately through SWAM portal. From there you can access. So that's good. Yeah. So one problem I am facing that this session is ends in 1 hour. If you want to join, if you want to join like after means this session will going to end after 1 hour, that is 9 p.m. So if you want to join at 9 p.m., so you join with this link I provided in the chat box. I will tell you when this meeting going to end. At that time you just join this session and we will continue through that link, that meet link. Okay, all right, so let us start today's session. So the first problem here is that in today's session we are having most of the problems are theoretical type, and assignment number 3 that you have to submit by 14th February, I think, that is also theoretical type. So first question is that which of the following is an approach for demand side management? And the options are load forecasting, load estimation, load shedding, load shifting. If you know the answer of this problem, you can type your answer in chat box, or you can speak also if you want. Just once is saying load forecasting. No, it is wrong. So I think it has, if you see the means of demand side management, there are five five types. Like first one is peak saving or peak clipping, and second is valley filling, third is load shifting, and fourth is a strategic conservation, and fifth is a strategic load growth or load building. So the correct answer for this problem is load shifting. So D is the correct answer. And the major points I just want to write here, that basically we do the demand side management so that we are have improve efficiency and cost effectiveness of energy usage on the customer side of the meter. And in general, this such control results in load reduction at time t. And if you see the peak saving or peak clipping, then in this management strategy, we are having reduction in both peak demand and total energy consumption. Reduction in both both peak demand and total energy consumption. And the examples are efficient control of air conditioners and water heaters. If you see the by the diagram, then the first figure denotes the peak saving or peak cleaning. We can see that the peak demand reduces by this control strategy, and by efficient control of air conditioner and water heater, some types of loads. So with the help of this peak saving or peak cleaving, you are having reduction in both peak demand and total energy consumption. And second one is valley filling. So in this case, if you see diagram, then this represents valley filling management strategy. So in this case, we can see that during offload, we are increasing the power demand. So in that case, we can say that there is no change in peak demand. So peak demand remains as it is, while we can see that there is increase in the total energy consumption because this overall area is going to increase. So that's why we can see that there is increase in total energy consumption. So in this case, you can write no change in peak demand, but however, increase in total energy consumption. And in the example for this valley filling management strategy, that electric vehicle charging, you can do electric vehicle charging in offload peak hours, offload duration, and so that we are having the increase in total energy consumption. And third management strategy is load shifting. And if we see the diagram, then this denotes the load shifting. So you are shifting the demand from the on peak hours to off peak hour, offload hours, off peak hours. So in this case, you can say that reduction in peak demand, but no change in total energy consumption. Because whatever the energy consumption during peak hours, you are shifting to off peak hours. So energy consumption remains as it is, while the peak demand reduces. So for this case, reduction in peak demand and no change in total energy consumption. and in this load shifting case they also increase in the load factor because average demand is going to increase and peak demand is going to reduce. So in this case, increase in load factor. We know that load factor is average demand. That is very important expression for expression average demand divided by peak demand. And the examples for this load shifting are deferrable loads. Can anyone tell any example of deferrable loads? We will see some problems based on that, so I am discussing a little bit theory here. Srinath, Sangeeta, Haritha, Harsada, Jaswant. So I am asking about what do you mean by deferrable loads? Anyone? Whatever you know, just tell. Don't hesitate. Otherwise, how I know that what you are understanding or not? Anyone? Deferrable loads means that is not essential type of loads like emergency type of loads. You can use the washing machine in some unusual time also. Like if you are using the washing machine or dishwasher during the peak time, you may use in the off peak time also. So that are deferrable loads. Like deferrable loads that allow time shift and consumption, and some non-deferrable loads that does not allow time shift interruption, like lighting system, kitchening system, and healthcare equipments. So that are non-deferrable loads. So deferrable loads like you can shift the time and interruption. So deferrable loads means like that allows time shift and interruption. So deferrable loads means you can having washing machine, dishwasher, and non-deferrable loads that we cannot shift the time of it, like medical healthcare equipments, and we are having this kitchen system, lighting system. It should run at that time. Now the fourth management strategy, strategic conservation. So in this case, we shift the whole load curve downwards. In a strategic conservation, there is reduction in both peak demand and total energy consumption. So we can see this this figure. This load curve represents this a strategic conservation strategy. So in this we can see that reduction in both peak demand and the total energy consumption because this we are shifting the whole load curve downwards. And the examples for this efficient lighting, air conditioning shifts whole load curve downwards. And just opposite to it, a strategic conservation, there is a strategic load growth. In this case, we are shifting whole load curve upwards. So this is a strategic conservation. We are shifting downwards, and in that case, we are shifting to upwards. So increase in both peak demand and total energy consumption. And we are shifting whole load curve upwards. So these are the important means of demand side management, and just keep it in mind so that you can solve the problems based on the means of demand side management. Now let us see the next problem. So in this problem, it is asked that which of the following devices can be controlled as one of the means of peak saving. So peak saving means peak clipping. So peak saving or peak clipping. So what do you think? You can type your answer in chat box. So what should be the answer? Peak saving and peak clipping. Peak saving or peak clipping. Sinath, Sangeeta, yes, I am getting the responses. Sinath, water heater, Jaswant Singh, C. Yes, C the correct answer. Both air conditioner and heaters. We have seen in the previous slide, like here, the first one is that if we use the efficient control of air conditioner water heaters, we can we can reduce the demand during peak hours, so that peak demand reduces. So the correct answer for this problem is by controlling the both air conditioner heaters, we can reduce the peak demand. That means C the correct answer. So this one is the old peak demand. Top denotes. Sorry. So this is the old peak demand, and after doing the peak saving or peak cleaving, this will be the new peak demand. So so in this demand side management strategy, we can see that there is reduction in peak demand and total energy consumption both. Reduction in peak demand. So now let us see the next problem. In the third problem, it is asked that which of the following can be considered as one of the ways for load valley filling. And the options are controlling the use of water heater, using efficient air cooling, electric vehicle charging, using efficient refrigeration. So what do you think, what should be the answer? You can give your answer in the chat box. So The problem is that which of the flowing can be considered as one of the base for load valley filling. And the options are controlling the use of water heater. B option is using efficient air cooling. C option is electric vehicle charging. D option is using efficient refrigeration.
C option.
Yeah, C option is correct. What is your name? Who gave the answer? So C option is correct, electric vehicle charging. So if do the EV charging during off-peak hours, we can we can have increase the average demand, like we can increasing the average demand here by increasing the demand during off-peak hours. So see the correct answer. Now let us see the next problem. So this problem is of different type. It is about the indoor and outdoor substation. So in this problem, it is asked that which of the following statement is are true regarding indoor and outdoor substation. And this problem is having multiple select answer. So more than one options are correct here. Multiple select question. So what are the correct choices you have to give? So the first option is that outdoor substation has higher reliability compared to indoor substation. B option is outdoor substation needs higher maintenance compared to indoor substation. C option is outdoor substation is suitable for cities with higher population densities. D
C is
option,
wrong.
okay, okay, C is wrong. And what are the correct options? And D,
This is Jaswant here. I think option B and option D are the correct answer.
yeah, very good. So B and D are the correct choices. So if you see the outdoor and indoor substation, like difference between both the substations, we can see that in outdoor substation a space requirement is more, while in indoor substation a space requirement is less. Outdoor substation is comparatively cheaper than the indoor substation, and since since this is expensive, so this also leads to less installation also. So this is expensive, so that also leads to less installation. Has anyone seen this indoor substation?
Yes, sir.
Where have you seen?
Gurgaon.
Okay, Gurgaon, yeah, nice. So I have not ch- means I have not seen this indoor substation. Most of the station I visited that is outdoor only. That is nice thing. So maintenance, if you see this outdoor substation, maintenance is more because it is outside. So means which eventually it will having more maintenance required due to dust and other things, pollution. Many things are there. And indoor substation is completely closed, so it requires less maintenance. While the fault location for outdoor substation is easier because the equipment is in full view. So the fault location is easier for outdoor substation. since the equipment is in full view. And for indoor substations, it is very difficult because the equipment is enclosed. And reliability, this is less reliable outdoor substation, and this is high reliable. So indoor station generally these are installed in cities with higher population, and because it requires less space, while outdoor space substation, if we are having a space, then it can be installed and it is also cheaper. That's why. So now let us move to the next problem. The next problem is that the depiction of fault location is and fill in the blanks in the outdoor substation than that of indoor substation. So what is the correct answer? So this problem, what should be the correct option? The depiction of fault location is fill in the blanks in outdoor substation than that of indoor substation. Options are easier, difficult, same.
A option.
Option A, yes.
Okay, good. It is easier in the case of outdoor substation. We know that because the equipment is in full view, so we can easily detect the fault location. So now let us come to the next problem. Next problem is that circuit breaker and isolator respectively can be operated, and the options are no load and rated condition, B is no load and on load condition, C is on load and no load condition, and D is rated and no load condition. So what should be the correct answer? If you want to discuss anything, if you have any doubt while solving the problem, you can ask.
Sir, I have a
Option
doubt
C.
regarding circuit breaker, isolator, and reclosures because
Okay.
some of the functions are similar.
No, circuit breaker is like what it means. Circuit breaker we used to run it on load operation, and isolator is on no load operation. So circuit breaker operation is like for to isolate means it works during the fault condition, while isolator work is during the we are doing the maintenance of circuit breakers. If something happens in circuit breaker, then you have to isolate the lines. Why, how you isolate the lines? With the help of with the help of isolators. So both function, the function of circuit breaker and isolator is different. Circuit breakers during
And sir,
trips during the fault.
reclosure also, reclosure.
Reclosure, I think it is somehow similar to isolator. Reclosure, I think in this course, Sanjeev Ganguly sir has not discussed about it, but I think it is somehow related to isolator. About circuit breaker, uh, you can read more in more in detail in this course, like switchgear and protection and power system protection. But circuit breaker isolators, there is nothing to confuse. Both having different operation, both have different work. So tell me the correct answer for this problem.
The C option is correct.
So I have confusion with the C and D. In the D, when it's written rated
Yeah.
and no load condition, what's the difference between the C and D?
Okay. So actually, these are just to confuse the it's like student. So rated condition, it is not necessary that it always operated rated condition. Means like we are asking about on or no load condition. Rated means like if the our distribution lines are not fully loaded, then it will also operate. It should also operate. It is not related with rated or non-rated. And our system needs not to be always at rated condition. It may be running at a lower value or somehow little bit higher value also. So C option is correct. So it is just for making the means like having adding the options and making the students confused little bit. So circuit breaker operates at no load operation. Sorry, on load operation, on load condition. Circuit breaker operates at on load condition, and its work is mainly to isolate the means isolate trip during the fault, so that it can isolate the areas where the fault happens. Isolate the function. It's better to write function. Function of circuit breaker is to trip where it get circuit breaker where it gets the tripping signal from which equipment. Can
From
anyone
relay.
yeah, correct. Trips and isolates the fault areas, while this isolator operates at no load condition. And its work is to perform the circuit breaker maintenance. So this is important. Circuit breaker operates at on load condition, while isolator operates at no load condition. I think next problem is related to this one only. An isolator can be operated at, so it is same problem anyhow. No load condition, on load condition, light condition, rated load condition. So isolator is operated at no load condition. A is correct. Now next problem. So this problem is little bit related to the function of the isolators. So in this problem, in a substation with different bus schemes, it is seen that circuit breaker is kept between two isolators. The isolators are used to protect the circuit breaker from faults, perform the circuit breaker maintenance. C option is protect the circuit breaker from lightning surge. D option is reclose the breaker after a fault. Anyone knows the answer can tell.
It should be option B. Perform the
C
circuit
option.
breaker maintenance.
Yeah, very good. B the correct answer. Perform the circuit breaker maintenance. One is Jaswant, and who is another one providing the answer? I should just keep the name, remember. Rahul Patil, Srinath, SCB. Yes. So now let us come to the next problem. In the next problem, the tie line and sectionalizing switches are respectively, and the options are normally open, normally closed type. B option is normally closed, normally open type. C option is normally closed and normally closed type. And D option is normally open, normally open type. Anyone knows the answer? You can try. If you are wrong, then nobody. It is not exam.
Sir, can you explain what is this tie line?
Yeah, tie line is used for connecting the different feeder areas, like different section. With the help of tie line, we used to connect the different section of feeders, different feeder areas, different areas you can say,
Sir, B
different.
option is correct.
Yeah, no, no, B is not correct.
Sorry.
Uh, so option C, both of them is normally closed.
No, no, option C is also incorrect. So you have two options right now. A and D, normally open, normally closed, normally both are normally open. I will discuss about the working of both switches. Both are very
It means D
important.
option is correct. Normally open, normally open.
No, all answers are given incorrect. A is correct. A is correct.
Actually, I have no idea about that, sir.
Yeah, no problem. So these are very important switches and little bit confusing. But if you remember the working of both switches, then you can easily uh, give the answer. What should it's normally open or normally closed. So I just want to make one table. One side you can write sectionalizing switches and this side tie line switches. Sectionalizing switches, they are normally closed. Normally it is closed. So sectionalizing switches you can say it is NC type, normally closed type, and tie line switches these are normally open type, and tie line switches normally it is open. And this one used in a fault condition. Used in the fault condition. And this one is used in the emergency condition or maintenance condition. So these switches are very important for our primary distribution system. And this sectionalizing switches it means what if fault happens it should open. So it is by default if it is normally closed type, then in normal operation it should be closed, and during fault it should be open. it is open during fault condition. We will see one figure from there you can understand in the next I think one or two problem. It is open during fault condition, and here it is closed during emergency condition or maintenance condition. So just right now remember this thing. Tie line switch is used for normally open type switch, while sectionalized switches are normally closed. In the next one or two problem, we will understand through diagram. So this is somehow related to previous problem. So when a fault occurs in distribution feeder, fault isolation and service restoration action depending on the fault location can be carried out by. And the options are given here. So what do you think? What should be the correct option? So fault isolation and service restoration. So we just in the previous slide we saw that fault isolation is done by tie line switches or sectionalizing switches.
Sectionalizing switches.
Yeah, sectionalizing switch. Correct. Very good. So for this now we have two options: sectionalizing switch and tie line switches. B and C options are we have, and then service restoration. Service restoration will done by this tie line switches. So option B is correct. So now we will see the last problem. So a sectionalizing switch is placed in distribution feeder to improve voltage drop, reliability, power loss, and power transfer. This is last problem based on this sectionalizing and tie line switch. What do you think? So a sectionalizing switch is placed in distribution system to improve voltage drop. So anyway, this is negative point, so it will not correct. We cannot use anything to improve the voltage drop, and we are have so we don't want to improve the power loss, so this is also in negative point, so it should not be correct. So we are two
Reliability.
options: reliability and power transfer.
Reliability. Yeah.
Yeah, reliability is the correct. Now we will see the diagram. I think from this diagram you can understand. So here we see we are three feeders. This is the network of primary distribution system. So we are having three feeders, like assume it as F1, F2 and F3, and all the feeders they are radial in nature, and these are having different load area. So here we can see that feeder 1 load area that is connected to this feeder 1, and second one is feeder 2 load area, and this one is feeder 3 load area. Now here feeder 2 feed primary feeder number 2 has been described in detail here, has been made whole. Someone mic is turned on, please turn off it. At the time when you want to speak, at the time you can speak, otherwise it is being recorded, so recording will not come clear. So this is feeder 2, so it is having different sectionalizing switch. So we can see that this is sectionalizing switch, and we know that sectionalizing switches are normally closed. So all the this like these are having, this is main feeder, these are laterals, then these are sublaterals. So it is, and it is getting, it is being, power is being provided this feeder number 2. All are all should be normally closed. That's why it can get power from the this feeder number 2. Otherwise how it will get power? So we can understand here the sectionalizing switch are normally closed type. And now the question comes is that why should work in fault condition? Suppose this fault happens in these sublaterals. Like these are sublaterals, I think. These are sublaterals. This is main feeder, these is laterals, and then sublaterals. So if fault happens in this lateral, then it should be open, so that it just get removed from the distribution system, and other parts will remain being provided the power. So we can understand the work from this diagram. The sectionalizations are normally closed type, and it should get open when fault happens in that section or in that lateral or sublateral, so that other parts will remain get provided the power from that feeder. So this is the work of sectionalizing switch. Now we can see that different feeders are connected through this tie line switch. So all are sectionalizing switch. Sorry, means first I want to cover this section. This is sectionalizing switch. This is sectionalizing switch. This is sectionalizing switch. So you can say in a feeder, in a particular feeder number 2, in a particular feeder area, all are sectionalizing switches. No tie line switches. Tie line switches used to connect the different sections. So there are 3 primary feeders. So all feeders are connected by this tie switches, and this should be normally open. It is already written. So tie switches are normally open. It is obvious where that it should normally open. Otherwise, it will become a loop or may something like that, and may you don't know that how this power voltage drop and other things will you have to take care. So different feeder area are connected to tie switch, and it should come in operation. When it should come in operation, when this feeder one this feeder one is unable to provide the power. So in emergency condition or in maintenance condition, it can get power through feeder 2. So from that we can understand, like suppose feeder 1 is unable to provide the power, so feeder it can take power from the other feeders. So tie switch bursts in emergency condition, like you require power, but there is fault. Your primary feeder is unable to provide the power. So from where you will get the power? You will get the power from other feeders through this tie switch. And tie switch in normal operation it is open, while in the emergency condition when you require power, so it should be get closed. So that is the operation of tie switch and sectionalizing switches. And below here also you can see this feeder 3 is connected through feeder 2 through this sectionalizing switches. This one. So this is the scene of tie line switches and sectionalizing switches. So a sectionalizing switch is placed in distribution system to improve the reliability. How it improves the reliability? Can anyone say?
Continuity of supply.
Yeah, it improves the reliability because continuity of supply is there because it removes the fault part. Another part it remains gets supplied through that feeder. Very good. So it improves the reliability. Now let us see the. I hope all points are clear about this sectionalizing switch and tie line switches. Now we'll move to the
Yes, sir.
next.
Now it is crystal clear. Thank you.
Yeah, good, good. So let us move to the next part. So the next problem is that the topology of transmission and distribution networks are. I think we have covered this problem in previous session also. So what should be the correct answer for this problem? The topology of transmission and distribution networks are transmission networks and distribution networks.
Sir, A option is correct.
Yes.
Yes, mesh and radial.
Oh God. I think we have 3 minutes time. So one problem I'm facing right now, I'm out of India, so it will be difficult to continue 2 hour session through one link. Yeah, so I just request all of you to join this meeting through this link, and we will continue through after that. All of you join through the other another meeting link. I am ending this session.
फोन भी बंद कर देगा।
Okay, all right. Okay, let it be. I am ending this session.
Sir, once show the single line diagram regarding the sectionalized and tie switches.
Yeah, sure. This tie switches is also using the transmission system also for connecting the different section of transmission level at the transmission level. Can you see it? Are you able to see it, Dharmender?
Yes, sir. Thank you, sir. Yes, thank you, sir. Thank
Yes.
you.
So, okay, can we move? So, if there is no doubt about this part, so we can move to the next part. So, we are
Yes,
here.
sir. Yes.
The topology of transmission distribution networks are of. So, first A option is correct, as you are all telling. So, mesh and radial type transmission networks. It is of mesh topology. So that what do you mean by mesh? We have various power flow paths are available. So in mesh topology, we are having various power flow paths. while in distribution networks it is of radial topology, and so that it having only one direction of power flow, unidirectional power flow. So now let us see the next problem. So I have written down the means like sorry, so it will make confusion. Yeah, so we have already discussed in difference between transmission and distribution network. So I have made the table also. So now coming to the next part, next problem. So it is the same uh, it is like to the previous problem also. So here in this problem, the distribution network topology is usually radial, and the options are due to unidirectional flow of power, e.g. protection coordination, cost effective in construction, and D is all of
D
the.
option, sir.
Yeah, D is the correct. Now if we see that primary distribution, we know that the primary distribution networks are mostly of radial topology, which results in unidirectional power flow, and this radial topology is preferred for its simplicity in construction, cost effectiveness, and protection arrangement. So all are these advantage of radial topology. Coming to the next problem. So now we have come to the different tariff structures. So in this problem, it is asked that which of the following tariff structure is considered as a block meter rate structure. And options are lower prices per kilowatt hour during peak demand. B option is lower price for greater usage. C option is constant price per kilowatt hour. D option is lower price for consistent load demand. So what do you, if you know the answer of this problem, you can tell. Most of the attendees who were present in the last class today, they are not present. So if we see the different tariff structure, so first I want to see how many of you replied. So you can type here on the chat box if you know. Option C, Srinath is saying option C. No, it is incorrect. So different tariff structures we have studied. That is first one is flat demand rate structure. Flat demand rate structure means a constant price per kilowatt hour. While a block meter rate structure is that lower prices for greater usage. And third is demand rate structure that is separate charges for demand and energy. Like there are two charges for power is different and for energy is different. So separate charges for power demand and energy. So separate charges for kilowatt and kilowatt hour. Season rate structure higher prices per kilowatt used during the season when system peak demand occurs. And time of day or peak load pricing structure higher prices per kilowatt hour used during the peak period of day and lower prices during off period of the day. Season data structure and time data structure is somehow same. In season data structure, it depends upon the seasons when the prices means price is fixed for a certain season. While time of the day structure in that case during the daytime the prices will vary depending on the peak period or off peak period. So now I think you are able to give the answer. So block meter data structure means lower prices for greater usage. So second, this one. So B option is correct. If you want to make the diagram for block meter as the structure, then you can make like this. In y-axis you can take charges in rupees, and here in x-axis you can make units consumption. So so for first 50 unit charges, like for first 50 units, the charges is like, let us assume 5 rupees per unit, and then its slope get reduces. So it reduces for another 40 unit or 30 unit, you can say. And this is for block third.
So there is a doubt, sir, regarding this.
Yes.
Generally, in our bill, whatever we get from a distribution company, so when you use the higher rating, yeah, greater uses, price is greater. But
Yeah, so
in this block meter rate sector, lower prices for greater uses, just reverse.
in which state you belong to, it depends on different state. Dharminder.
UP, get rid of
Okay.
Uttar Pradesh.
Okay, I think like for first thing is that fixed charges. I am from Bihar, so they used to take charge according, means like first there is fixed charges. How many, like for 4 kilowatt hour, for 5 kilowatt hour, there is different fixed charge. That fixed charge will come either you consume power or not. But means that is fixed charge, and variable charge, that amount of energy, amount of power consumption they will charge, they will charge accordingly. And so like 4 rupees per unit or 5 rupees, like that. So I don't know about UP, but in Bihar it is like that. So it depends upon the state and countries. Different have different rules, and price, energy charge is also different everywhere. Means like you are saying that if you are increasing the, means like uh, for another units, if you are having higher power consumption, then they will increase the price, like that you are saying.
Yeah, per unit charges increases. Yes, suppose that if you use the 100 units, it is about 5 rupees per unit. More than 100 units and less than 150, 5.5, and then 6 rupees, like that.
Okay. And just I am to I am never of your state, there it is not that, like, means there is fixed charge, that is it depends upon your house, that how big is your house. Depending upon that, you have to uh, take the connection, like 2 kilowatt, 1 kilowatt, 4 kilowatt, 4 kilowatt
Yes,
hour.
yes, yes.
So that is fixed charge. Another is like based on the unit consumption, they will take the charge. That vary upon the number of units. More the number of units, more will
Yes,
be the
sir.
charge. But it is not going to decrease. It is fixed for per unit. And the government also provides subsidy, so that will also there. So these are different tariff structure just for our study material. It is not like that it is, means I have not written down examples. It is apply in which state or which country. We have to investigate. We have to do research, like where what is type of tariff structure in India is there. So it is like that. So for block one, we can say that like first 50 units. They are charged at rupee 5 per unit, you can say. And for block 2, let us say 30 or 40 units, it is charged at rupee 4 per unit. And in block 3rd, next 30 units,
Sir, screen is not visible, sir.
rupee 3 per unit. Okay, I think I have to connect it again. Yeah, it lost. Are you able to see, Dharminder?
PPT is not showing, sir.
Oh, it's visible from my side, Dharmir.
Is it visible to other participants?
Yes, it's visible to me.
Okay, because it is showing here. I am presenting to everyone. So moving to the next part. Sorry. So here in this next problem, it is also related to tariff structure. So which of the following is considered as a flat demand tariff structure? And the options are lower prices per kilowatt hour during peak demand, lower price for greater usage, C is a constant price per kilowatt hour, D is lower price for consistent load demand. So what is the correct option for this problem?
Option C.
Yeah, correct. A constant price per kilowatt hour. C is the correct answer. Now next problem, question number 16. Which of the following is a decision factor for the conductor size selection? And the options are physical barriers, substation capacity, conductor rating, D is feeder limitation. So when you are selecting a conductor, so what should be the decision factor while you are we are selecting the conductor? So let me provide some material for, some notes for this problem. I picked this from the slide. So you can see that different factors affecting conductor size selection. So if you see this conductor rating that affects the conductor size, one of the decision factor for conductor size selection. So C is going to be the correct option. Others are incorrect. Physical barrier, substation capacity, there is nothing relation with the conductor size selection. Feeder limitations, there is no relation with the conductor size selection. Conductor rating, that is one of the decision criteria. Now the next problem, which one of the following is not a decision factor for the conductor size selection? So conductor rating, obvious, it is one of the decision factor for conductor size. Power losses, it is also one of the decision factor for conductor size selection. Voltage drop, it is also a decision factor for the conductor size selection. While this D option is incorrect. So substation capacity is not a decision factor for the conductor size selection. Now moving to the next problem. So in this problem, which of the following is not a substation equipment? And the options are power transformers, CT and PT, C is circuit breaker and isolator, and D is water reservoir. So this one I just want this answer from your side.
Is option D, sir. Is water reservoir.
Yeah, correct. So water reservoir is not a substation equipment. So typical substation include the following equipments: power transformers that is used to having vary the voltage that is used to for the voltage level, circuit breakers and isolators, station buses and insulators, current and potential transformers. So this one is CT and PT, that means current transducers, current transformers and potential transformer. Shunt capacitors that is it for improve the power factor, grounding system, lightning arresters and or gaps to prevent the system from lightning, protective relays, a station batteries to provide the auxiliary supplies. So these are the typical equipment for the substation. This is similar to the previous problem. Which of the following is a substation equipment? Options are bus bar, current transformer, battery bank, and all of these.
Option D, sir. All of these.
Yes, very good. Option D is correct. All of these. Now coming to the 20th number problem. Which of the following factors affect the variable losses in the distribution network? Options are quality of transformer core material, load power factor, substation capacity, feeder design. And one thing I want to tell here that this is multiple select question. More than one choices are correct. In the exam, how you identify that this is multiple single choice question or multiple select question? Means one option is correct or more than one option correct.
It is written there
The radio
factors.
button is square button.
Yeah. So that is the first thing. Radio button means single answer is correct, and this one denotes multiple choices are correct. So just this is very important, and it is also written there. This is multiple select question or this is multiple choice question. So that thing is also there. So this is the same thing is followed in GATE exam, and here this NPTEL exam, the same thing is followed. And you know, in your NPTEL exam is also, I think they put most they put center where the GATE exam is happening. So most probably they put there only, like TCS Ion, digital this thing. So uh, anyone knows the answer for this problem?
A, B.
No, you just read it carefully. Variable losses, not the constant losses.
Okay, okay, yes.
Yes, B is the correct. B is the correct, and one more option should be is correct. So feeder design is also the correct option because based on the feeder design, like there are different designs of feeders. The means your primary feeder, lateral, sublaters. The way you connect to the different loads that also affects the power loss in the network because how much is the length of your distribution line that affects by your feeder design, and load power factor is the also important that also vary the losses in the distribution network. So these are B and D are the correct option. Now, next problem. Which of the following customers can be called as a prosumers? So this is one of the commonly used terms nowadays. And the options are a customer who participates in demand side management. B option is customer with rooftop solar photovoltaic generation. A customer who can produce, sell, and consume electricity. A customer who can shift its load demand. Yes, Srinath, Jaswant, Sangeeta, Dharmender, only four attendees are here. So what should be correct option?
Option D.
No,
Option D.
option D is incorrect. Dharmender,
Yes, sir.
what do you think? What should be the correct? Jaswant is saying option D.
Sir, option. If not D, sir, can I go for another one?
Yeah,
Option A, sir.
no, it is also incorrect.
B
For,
B is 100% correct.
no. C is correct. I don't think but for our means I am a researcher, so this term is very common for us. We heard so many times. C option is correct. Prosumer.
Yes, sir. Only C is correct.
Yes. This is not multiple select. If any multiple select question is there, I will just tell you first. This is single
Okay, sir. Okay, yes,
multiple
yes.
choice. Prosumer. So prosumer it is made from two words. So prosumer means producer, and consumer, that word came from this consumer. So this term is yeah, means nowadays coined, but it was not earlier. So we have only one term by their consumer. But nowadays, what is happening? This consumer is being converted to prosumer. How? Because by the installation of solar rooftop or having wind gen means this is typically not common in India. But in India, we are having solar photovoltaic in our household. So if you are having excess power demand, means excess power being generated, that is means after fulfilling your power demand at home, then you can sell it to the utility companies. So that in that way you will become a prosumer, not a consumer. In consumer, only one direction of power flow, that is from utility company to your household. But if you are a prosumer, like if you are having a solar photovoltaic any things like from where you are generating power and you are fulfilling your household demand, and the government or utility companies providing some incentivities or something like if you are having solar photovoltaic in rooftop, then we provide some incentive, so they are getting motivated, consumer getting motivated, and they install some solar rooftop and they feed the power to the grid after having the after providing the power to household, or they sell it to the grid. So in that way they become prosumer. And in this we can say that customer is connected with a bidirectional communication link, and the utilities are providing sufficient appropriate incentives so that they can sell their power. So prosumer means a customer who can produce, sell, and consume electricity. So all the things are there. So just remember this thing. Prosumer, this is made from two words. Pro means that came from producer. Sumer means that came from consumer. So that is it. Now let us move to the next problem. The flowing busbar scheme does not get interrupted due to busbar faults. So this is multiple select question. Here in this problem I have not made proper notes, but you can kindly refer this lecture number 8. Slides of lecture 8 it is also fine. There professor has delivered about the different types of bus bar arrangements, switchgear arrangements like single bus scheme, single bus with a sectionalizer scheme, single bus with a sectionalizer and two power transformer scheme, main and transfer bus scheme, double bus bar scheme, ring bus scheme, break and half scheme. So if you see from the options, the single bus scheme, that is one of the simple bus bar scheme. So from the options we can go one by one. So we have what should be the option correct. Single bus scheme. Single bus scheme, if faults happen in bus bar that take whole the substation out of service. So this is incorrect. So here in the fault in bus bar would take the whole substation out of service. And the second one is that single bus with transfer bus scheme. So here we are with two bus bars. Two bus bars. One is main bus that always energized, and second one is transfer bus. It is not energized. It is energized through tie breaker by the main bus during circuit breaker maintenance only. Not energized. It is energized through tie breaker by the main bus during circuit breaker maintenance. So this one is also incorrect. So C option is double bus bar scheme. So it is having two bus bars and both are always energized and connected by tie breaker. And it has advantages of operational flexibility, operational flexibility, possibility to move possibility to move loads between buses. So this option is correct. C option is correct. Now D option, we see double breaker scheme. For the figure, you refer this in lecture number 8. From there, you can better understand. So here also one feeder is connected by two circuit breakers with respective bus bars. So this one, D option is also correct. So double bus bar scheme, double breaker scheme does not get interrupted due to bus bar faults, and they remain provide power to the distribution areas. Now let us see the next problem. Which of the following will you consider as the most important decisive factor for the choosing the permissible length of a ruler distribution feeder? This is also important problem. This is the second last problem. Just we have two more problem and then we will finish it. Anyone tell? Anyone knows the answer?
Voltage drop, option A.
Voltage drop. Yeah, very good. Just one correct. Voltage drop is correct. So if you have been gone through the slide, then you know these two important points. So first point is that usually primary feeders located in low density areas. Low density area means that rural areas. Low low density rural areas that are restricted in length and loading by permissible voltage drop rather than thermal restriction. So their voltage drop matters more. Whereas primary feeders located in high low density areas, for example industrial and commercial areas, their restriction by thermal limitation, not by the this voltage drop. So just remember these 2 points. Low load density areas, that is rural areas, there we take care of the voltage drop, while high load density areas, where there will take where there we have to take care of the thermal limitation. Thermal limitation has another name also. Does anyone know? Ampacity limit. Have you heard this term, ampacity limit?
No, sir.
So this is same, that ampacity limit or thermal limitation both are same. So why we look into the voltage drop in low load density areas and why we look this ampacity limit in high load density areas? Do you have some idea? Because I think if you know the if you know the logic behind any theoretical problem also, then you have to not mug up or don't need to remember all the things. It is very simple, just put some common sense. I think
Sorry, sir. What is the question?
why we consider the voltage drop in low load density areas and ampacity limit in high load density areas while
Basically, low load density area like distribution systems and transmission mainly considered thermal limits.
Yeah. So
So
yeah, tell me.
for low density, sir, I can say actually when we talk about rural distribution, the load uh, are very far away. So longer is the line, more is the voltage drop.
Yeah.
So uh, that's the first one, and the second one in the thermal limitation, because the load is concentrated in a particular location, and the load is basically high
Yeah.
at that place.
Yeah. Very good. Just one thing. He is telling correct. So that is the thing. Means low load density areas means you have long length line, so you have to take care of voltage drop. While the density is high, then you have to consider about the power, and then more power is flowing through that through a lesser area. Then you have to take care of the ampacity or thermal limit. So that is the simple logic. So moving forward to the last problem, that is question number 24. A lateral implies to, and the options are main or trunk of a distribution feeder. B option is branch of a distribution feeder. C is a distribution transformer. D is line insulator. So anyone can tell. This is the last problem. Then we will finish today's session. Anyone has idea? I think uh, you have not seen the video of NPTEL only lecture. Otherwise, it is very simple. So the in the case of distribution system, the main primary feeder branches into various primary laterals that in turn separates into several sublaterals to serve all the distribution transformer. So the correct answer for this is a branch of a distribution feeder. And this main or trunk of distribution feeder that we call it a primary feeder. This we called the primary feeder. And if if a lateral is if a lateral is separated into several parts, that we call it sublaterals, and that is connected to distribution transformers. So let us see one figure. From the figure it is easy. So here you can see. So this is the distribution system LV bus. Distribution system LV bus, and then this is having primary feeder. So in India, what is the voltage level of this distribution substation LV bus? Can anyone tell?
415 volt.
What?
Sir, is for 415 volt.
No, no. This is primary
Okay,
feeders is generally,
11 kV.
yeah, because this distribution transformers convert this voltage level to our utility level voltage.
Okay, yes.
Yeah. So this is primary distribution system. So they operate it at 11 kV, and from after the distribution transformer we are having secondary distribution system. So that is the secondary distribution system side. So they operate at 400 volt line voltage.
Sir, but then distribution substation is supposed to be HV bus instead of LV bus.
What?
This distribution substation LV bus that is written there, is it not supposed to be HV bus? Is high voltage, right? 11 kV is we consider as high voltage.
Yeah. So but this is for the to run gun and book accordingly. So I have just want to take it familiar to our Indian scenario. That's why it create
Okay.
confusion. Don't write this voltage level. Thank you for reminding this. But this is for Gonen book accordingly. So they have made this like. But in India, whatever the scene that is like now, we are having 11 kV voltage, and then we are having distribution transformer. So that's take up voltage down to 400 volt, right? Distribution system voltage level is 11 kV 400 volt. That is correct now. So
Yes, sir.
accordingly from there I just considered that part. So this is taken from the book. So that is our not main mm, that is not our main part. Here in this problem, I just want to make you all understand that we are having this primary main feeder, this one, and then these are having laterals. So these are having laterals. Primary main feeder is having the several branches. So this we call as several laterals. This we call laterals. And then we are having transformer switches. So these are called distribution transformers. And when these laterals is divided into several branches, then we call it as several sublaterals. So this is the laterals and this is sublaterals. And in somewhere it is fuses are connected, so we call that means where the fuse is connected, so it is lateral fuses or sublateral fuses or transformer fuses at which part is being connected it accordingly. I think nothing is in this is more. So in the primary distribution system we are having main primary feeder, so it is having several branches that we called laterals. And the several laterals, if they are further divided, they called it as sublateral. There may be one, two, three depending upon the design of distribution system. So sublateral. There may be more, and these sublaterals are connected to distribution transformer. So that is the general layout of a primary distribution system. So that's all. This is the last problem. Thank you for attending today's session. If you have any doubt
Thank
or
you,
any
sir.
other concern, you can ask. Otherwise, we will meet in the next session.
Thank you, sir.
Thank you, everyone. Bye. Good night.
Good night, sir.